This lesson is on factoring perfect square trinomials, the difference of squares, and the sum and difference of cubes. Let's get started by factoring the difference of two squares. Here we go. So when you have a form a squared minus b squared, it factors into a minus b and a plus b. Let's see why. The beauty of factoring is you can always check your work by multiplying it out to see if you get back to where you started. So a times a is a squared. A times b is a positive ab. Negative b times a is a negative ab. And negative b times a positive b is a negative b squared. The middle terms will add out, so I get a squared minus b squared. Done. This only works for the difference of squares, never the sum. So, here we go. First one here, I notice that x is squared, and I have a negative 25, so the signs are going to be different. 5 times 5 is 25. And the middle term will add out. If I do the cradle, 5x minus 5x will add to 0. Let's do the next one. So 49 is a perfect square, and so is 36. So 49x squared would be 7x. 7x. I have a minus, so the signs are different. See, the same rules apply here. I could think of this as 49x squared plus 0x minus 36. See, I have different signs for this negative. Cool, so these guys are going to be different. 36 breaks down into 6 times 6, so if I do the cradle again, I'll get 0 in the middle, just like it wants to do. Now let's look at C. Well, this is the sum of two squares. So I say to myself, oh, okay, so let me try x plus 9, x minus 9. But that doesn't work because a positive 9 times a negative 9 is a negative 81. So, Well, then you say, well, what about x plus 9 times x plus 9? Well, then my cradle isn't going to work out because I'm going to get 18x. So that's not going to work. So what we say is that this polynomial or binomial is prime. Now let's take a look at perfect square trinomials. I love that we have these formulas. However, sometimes when I'm in a test situation, I can't recognize that it's a perfect square trinomial. So I can just factor it regular and go, oh, in the end, oh, that was a perfect square trinomial. But there are some dead giveaways. Here we go. So let's look at this first one. I'm going to factor it normally. It's a positive here. That means the signs are the same and they're both positive. Y squared breaks up into y times y, and 16 breaks up into 4 times 4. When I test my cradle, 4y, 4y, I get 8y. I'm done. But we want my little sophistication guy up. He's got a bow tie on. Y plus 4 quantity squared. This is a perfect square trinomial. So, because let's take a look at it. This is y squared, which is nice. 8 can be written as 2 times y times 4. And 16 can be written as 4 squared. So if I look at my little happy formula, there's the 2, there's y, which is a, 4, which is b, 4 squared. So it is a perfect square trinomial. I dissected it. Let's do the next one. And we want to make sure before we even start these, and I didn't on the first one because the leading coefficient was 1, but we always want to make sure that nothing can be factored out of every single term first. Because if it can, and you don't do it, it makes your factoring life a living heck. So here we go. So I go, well, 9 is a perfect square, 3 times 3. X, 16, 4 times 4. I know they're the same sign. They're both negative because there he is. Now check your little cradle thing. So negative 12x. Outside is a negative 12x. We get a negative 24x. Boomba. Sophistication, people, right? We're going to write it like that. Perfect. Let's take a look at this next one. I look and I can't factor anything out. So 9 is a perfect square. 64 is a perfect square. Everything's positive. Check your cradle. Are you checking your cradle here? 48x. So this becomes 3x plus 8 quantity squared. Very nice. Next one. Well, I look at it and I see that I can actually pull out a 2. We'll get remaining 4x squared minus 20x plus 25. Dead giveaway, we have a 4 and a 25, and they're both perfect squares. So 2x, 5, 5. But what are the signs? They have to be the same, and they're both negative. Check your cute cradle. I always check my cradle. Negative 20x. Perfect. Level of sophistication comes into play. 2x minus 5 quantity squared. Notice this was a two-step problem. I had to factor out the 2 first, write down what was left, and then factor from there. Now let's talk about the sum or difference of 2 cubes. Now this one is a little intense. However, I just want you to relax, and I have a little trick for you. So first we're going to look at if we have cubes in here. The first thing I'm going to do is write both of them as cubes. 64 is 4 to the 3rd power, so I'm like all excited. And it's a difference of cubes, so this is what I do. Here's the formulas. I have 2 formulas. I would be using this second formula down here. I'm going to write it out without the cubey guys. Good? Then I'm going to work off of this guy, this first piece. Forget about we're going to kind of forget about them for now. Okay? Good? We're going to square the first, multiply the middles together, multiply these guys together, square the last guy, which is 16, and adjust the signs. How do I know what signs to put in here? Well, this first sign right here, the negative, always goes with what we started with. Okay, you keep that sign, what you started with. So same sign, S. This guy right in between here is always going to be the opposite to where the first sign. So it's going to be a plus. O for opposite. S for same. And then the last sign here, AP, always positive. Good. And the last trinomial here, this guy is never factorable. So don't even try in the end. The remaining trinomial is never factorable. So when this is it, guys, right here, you're done. Now you might say, well, I can't even believe that's going to multiply to get back to x cubed minus 64. Well, it will, and I can show you that in the next problem here that will have less bigness to it. So first thing we're going to do, let's factor it first, and then we'll remultiply to see if we get back to where we started. This is the sum of cubes. So we're going to do x cubed plus 2 cubed, because 8 is 2 cubed. What do? We write it down without the cubey guys. Same sign, s. Good. Now we're going to have that ugly trinomial. Square the first, multiply them together, 2x, square the last, 4. Same sign, opposite sign, always positive. Bing! All right, so let me show you over here that it does indeed work. We have x squared minus 2x plus 4 multiplied by x plus 2. So 2 times 4 is 8. 2 times negative 2x is a negative 4x. 2 times x squared is 2x squared. 4 times x is a regular 4x, right? This will be a negative 2x squared and x cubed. Oh, look at that. X cubed. Add out. Plus 8. Perfect. That's my nice check. This is my factored answer. The second trinomial is never factorable. Now let's do C. What happens if I have a leading coefficient in there? Well, the minute I see a leading coefficient, I try to factor anything out. This one you can't. So we're going to write it with cubey, guys. Are you ready? 8 is 2 cubed. Then I have my little x cubed. 27 is 3 cubed. So you write it down without the cubey guys. Now, we're going to square the first guy right here, so that's 4x squared. Multiply these two together. 6x. Square the last guy, 9. Now we just have to adjust our signs. This first one is the same sign. Second one is opposite, so that would be negative. AP, always positive. Bing! There it is. There's my factored answer for this sum of cubes. Now here is a whole list of guidelines for factoring that when you do your assignment for this, you should have this out. Factor out the greatest common factor first. If what is left is a trinomial, check to see if you can factor that. If what is left is a binomial, see if it's a difference of squares. You may have to do this difference of squares a couple of times. If what is left is a binomial and it's not a difference of squares, check to see if it's a sum or difference of cubes. For trinomials, factor out the greatest common factor first, and then do the sign things. Check to make sure with your cradle it will help you, and then the sum and difference of cubes. So this is kind of all laid out. I notice in here, this should be difference of squares. Now you can do the MyMathLab assignment on this section. Ask lots of questions and do the math and maybe have a little fun with it.